Hi guys, today I'm joined by one of my former students that I now tutor sometimes, my little friend Marley. Say hi, Marley.
Hi.
Good, so today we're here to help you with equivalent fractions, and we are going to be using an aerial model. Do you know what an aerial model is? You have to talk, they can't hear you. She says no. She doesn't remember what an aerial model is, so let's remind her. An aerial model is when we basically use shapes to show fractions. So we're going to be doing equivalent fractions. What does it mean to be equivalent? Good. It means that it's going to be equal. So we're looking to find what fractions are equal, and today we're going to be using an aerial model. We're going to be using shapes. So let's say we have two shapes. And we want them to be the same shape because you can't compare something that's not the same. You heard of comparing apples and oranges. It's hard to do that because they're two different fruits. They don't really have the same purpose. I eat an apple because it's sweet. I eat an orange because it's kind of acidic and juicy. Yeah. So you can't really compare them. So same thing with fractions. You want to compare things that are similar. So when we're looking for equivalent fractions, we kind of want to have the same shape when we're using the area model. So let's say that I will have a bar. And in our case, our bar is going to be a, what shape is that?
Rectangle.
Good. So I want to kind of have the same kind of rectangle. And I normally like to draw them on top of each other and use the lines on my notebook paper because that kind of helps me make sure that my rectangles or my shape is very similar so that I can compare them. Okay, so we want to start off with having the same hole. It's kind of like if you had a candy bar. If your little brother has a king size, but you have a regular size candy bar, it's not really comparing the same thing, is it?
No.
So you want to make sure it's the same size. And then we want to show that fractions are equivalent or equal by making sure that they look the same, even if they aren't partitioned the same. So we're going to take this first shape and I'm going to cut it into or partition it into thirds. And here I have this same shape, but I'm going to partition it into 6 pieces. So even though the shapes are partitioned differently, cut differently, we can show equivalent fractions. For example, if I shade in just this bar on my first rectangle, and I wrote a fraction for it, what would the fraction for this bar be, Marley?
1/3.
Good. Tell us why it's 1/3.
Because there is 3 rectangles and you are only shading in 1.
Very good. In total, there are 3 rectangles, which is our denominator. And I shaded 1, and that's what I'm focused on. So 1 out of 3. So that fraction is 1/3. So if I wanted to find an equivalent fraction, I would need to shade the same amount on this bar. Now, I'm not saying that I need to shade one part, because if I only shaded one part, it wouldn't look the same as this first one, would it? No. Go ahead, Marley, and shade it in so that the same amount is shaded in on this second bar. Good. When she shaded in the same amount, she actually had to shade in how many parts?
2.
Good. You had to shade in 2 parts out of how many total?
6.
Good. There are 6 boxes total. But even though she shaded in 2 parts out of this 6 to 6 of this rectangle, and we shaded 1/3 of this, when we look at the bars, the same amount has been shaded. Do you see that? That's because these are equivalent fractions. They equal the same thing. What this shows us is that 1/3 is equal or equivalent to 2/6. Good. Let's try another one. This time, let's use some circles. So in this one, again, we want to have the same size and the same shape. So I'm going to try to draw 2 circles that are similar. How's that? Not bad. 2 circles that are similar. But we're going to partition them differently. So I'm going to cut this one. Let's cut this one like this. And we're going to pretend that I'm great at cutting and making them equal. And then we're going to cut this one a little bit different. taking my time here so that we can have them as close to equal as we can. Okay, now that we have them equal, what we want to do is we want to show equivalent fractions. So on this one, I kind of want to shade in two pieces because I'm really hungry and I like apple pie, and I'm really thinking about having 2 slices of apple pie when I go home today. So we're going to shade in 2 slices of this one. So if I were to write a fraction for this shape, what would I have?
Oh.
A fraction for the shaded part.
2/4.
Good. There are 2 parts shaded, 4 in the whole thing. So this shows us 2/4. If I want to find an equivalent fraction, I want to shade in to show the same amount shaded as the other one. Go ahead now and make my second circle look like my first one. Good. Now what Marley did is shade here, and she shaded in some parts, but usually I tell my students try to make it look just like this one. So we kind of want to shade it in the same spot on this one, just because it makes it easier for us to compare. So now that we have them shaded in, we can see that they look the same amount shaded, but they were partitioned differently. So what this really shows us is what fraction does this circle show us for the shaded part. Good. We can see that how many parts are shaded?
4.
Good. 4 parts are shaded, and then the whole thing there are
7. 4.
1, 2, 3, 4, 5,
6, 7, 8.
Good. There are 8 in the whole thing, so our denominator is 8. What this shows us is that 2/4 is equal to 4/8. Now, let me really blow your brain. There's another equivalent fraction that I also see just by the shading. When I shaded in my 2 parts here, if this was the line I used instead of the other line, same thing here, I would actually have 1 part over here and another part over here, which means I would have 2 parts total. That would be my denominator. And if there are 2 parts total, 1, 2, or 1, 2, and only one side of it is shaded,
That would be a half.
good. Both of these fractions are equivalent to 1/2. So 2/4 is equal to 4/8, which is also equal to 1/2. This is how you use an area model to show equivalent fractions. You simply shade it in so that the shaded in part looks the same. And if they are the same, then the fractions are equivalent or equal to each other. Let's take a look at 2 of our examples that we had on our study guide for tonight. Ignore the number lines. We did that on a previous video, but now we're going to look at the shaded parts. So if we look at number 3, we see that they're both rectangles and they are the same size. We know that this first shape is showing us 3/4. It's already labeled for us. We can see that 3 parts are shaded out of 4 total, so that's the fraction for that. We want this rectangle to be shaded just as much. So I want you to show me on this rectangle, how much would you have to shade to make it look like that first one? Very good. So when we look at what she had to shade to make it look like that first one, and I'm just going to go over it just a little bit so you can see it nice and clear. She's absolutely right though. Now it looks like 3 bars. If you look closer, you can kind of see those 3 bars there, can't you? But they're actually partitioned a little bit differently because they also have smaller pieces. So really we have 4, 8, 12 bars shaded in, so that's our numerator, and a total of 4, 8, 12, 16 bars. What that shows us is that 3/4 is equivalent to 12/6. Good.
16.
Oh, sorry, 12/16. Molly's right. I'm so ready to go eat my apple pie if you can't tell. Now let's look at number 4. We see that it's shaded. There are 2 parts in the whole thing. 1 part is shaded, so 1/2. And we want the second rectangle to look just like that first one. So go ahead, Marley, and shade in that second one, make it look like that first one for us. Awesome. Look at that shading. That's awesome. So we can see that. We can almost see where that first bar is, can't we? That it matches that. But it was partitioned a little bit different. So it's not just one bar. It's 1, 2, 3, 4 as my numerator with a total of 4, 8. Very good. So we know that 1/2 is equal to 4/8. Awesome job. So this is how you use area models to show equivalent fractions. I hope that helps you a little bit, and I hope that helps you get prepared now for equivalent fractions. Have a great day. Bye, guys. Say bye, Marley.
Bye.